title of this note is Rational Functions Asymptotes, and the outcome is that from an equation, you're going to be able to analyze the asymptotes of a rational function. So take a look at these graphs of rational functions. There are a couple different kinds of asymptotes. In this first one, there's a vertical asymptote right there on the y-axis. There's also a horizontal asymptote right here on the x-axis. So that's what we mean when we say we're looking for the asymptotes. Notice that the asymptotes don't have to be on the axes. They can be elsewhere. They're always sketched with dotted lines so that we know they're not a part of the graph. You can have multiple vertical asymptotes, like this graph right here, or it's possible that you have no vertical asymptotes. We're also going to have holes. You can see a hole there in the graph and a hole there, and we're going to get to that in our next lesson. So first we're going to talk about finding a vertical asymptote. The way you find a vertical asymptote is you're going to completely factor both the numerator and denominator. It's very important that you do not simplify, you just factor. You are looking for unique factors of the denominator. So let's take a look at an example. Oh, before we factor, remember you cannot factor out an x squared. So this is a little joke, every time you do this, a kitten dies. So no dead kitties, please, in class. So let's take a look at this. Do not kill kittens. When you cross those out, kittens die. Don't do it. You have to factor the numerator and denominator. So looking for two numbers that multiply to -6 and add to +1. So 3 and -2. And then in the denominator, looking for factors of -2 that add up to be -1. So this is that rational function in factored form. Notice that the x minus 2 repeats in the numerator and denominator. So when we said we're looking for unique factors, this one does not count because it appears in both the numerator and denominator. The x plus 1, however, is a unique factor. Remember, we cannot divide by 0, so we want that to avoid being 0. If we subtract 1, that means that at x equals -1, there is a vertical asymptote, because that would cause division by 0. The reason x minus 2 is not a vertical asymptote is because it'll factor out, so it's not actually going to cause division by 0. We also have horizontal and slant asymptotes. Here's a picture of the different kinds of horizontal and slant asymptotes. You can have a horizontal asymptote on the x-axis. You can have it off of the x-axis, or you can have what's called a slant asymptote. Now, vertical asymptote you never, ever, ever, ever may cross. Horizontal and slant asymptotes are more of suggestions. You might find graphs like this one in the middle. It could do that, where yes, it crosses the horizontal asymptote. Horizontal asymptotes are more about what's happening on the ends of the graph as you go out closer and closer to positive and negative infinity. Vertical asymptotes you never may cross. Horizontal and slant asymptotes you may occasionally cross. They are more of suggestions. So how do you find a horizontal asymptote? You're going to compare the degree of the numerator to the degree of the denominator. You don't need to write this down. But the degree, we're just going to call the degree in the numerator n, and the degree in the denominator m. So if n is less than m, then your asymptote is on, your horizontal asymptote is on the x-axis. If they're equal, you're going to divide your leading coefficients. That's what that says. If the one in the numerator is greater than the one in the denominator, there's no horizontal asymptote. Instead, it's a slant asymptote. And when we start solving these, you can abbreviate HA, SA for horizontal and slant asymptotes. So let's look at an example of these. All right, here's an example. Okay, you're going to compare the leading coefficient, the leading terms. So in the numerator, the leading term is 4x, and the denominator, the leading term is x squared. This degree is 1. It is less than 2. So this is an example where your horizontal asymptote is at 0. It's on the x-axis. What if your leading terms have the same x? You can just pull out the leading terms, and you get 4. So there's a horizontal asymptote at y equals 4. And the last scenario, what if the degree in the numerator is greater? This would be an example of a slant asymptote. So we have the equation when it's at the axis, the equation when it's not at the axis. What about a slant asymptote? We can find the equation of a slant asymptote. You are going to have to do polynomial long division. Your answer without the remainder, you're going to ignore the remainder, is the equation of the slant asymptote. So let's look at an example of that. So this is the same example we just saw. We know it has a slant asymptote because x squared is greater than x, has a higher degree. So I know it is an SA, a slant asymptote. So I'm going to do long division. You may have seen long division in elementary school with numbers. It works the same way with polynomials. You're going to start with the first term. You're going to do x squared divided by 4x. You might want to do work off to the side. What's x squared divided by 4x? You have an x in each that factors out, and you get 1/4 x. X over 4 is the same thing as 1/4 x. So that goes up here, 1/4 x. Then you're going to multiply this by both terms. So 1/4 x times 4x, 1/4 times 4 is 1, x times x is x squared. And then 1/4 x times negative 4, see that minus sign, 1/4 times negative 4 is negative 1x. Then the next step in long division is you subtract. So x squared minus x squared is 0x squared. I don't need to write anything. Watch your signs very carefully. 3 minus negative 1. Subtracting a negative is like adding. So now we're going to repeat the process. What is 4x divided by 4x? It's 1. The solution goes up here, and again you multiply. 1 times 4x is 4x. 1 times negative 4 is negative 4. And then you subtract. 4x minus 4x is nothing. Negative 4 minus negative 4 is also nothing. So this is our quotient. If we had a remainder, we would just ignore it. So that's the equation of our slant asymptote. Notice it's the line, and the equation of the line is 1/4 x plus 1. That's it for these notes. You can go ahead and draw your line.